Lab 1. Lab Safety, Scientific Method and Measurements. In this lab, you will learn 1. How to safely work in the lab. 2. How to use the scientific method. 3. How to measure weight and volume. Section 1. A. Activity 1. Pre-assessment. 1. Name one piece of lab safety equipment. What is it used for? 2. What is one hazard of the lab and why it is hazardous? 3. Discuss the answers to questions 1 and 2 with the class. B. Safety precautions. 1. Take care as you move around the lab. 2. Wear all appropriate safety equipment. C. For this activity, you will need the following. 1. Access to the internet or a downloaded version of the safety video. 2. Lab safety equipment. 3. Lab safety agreement. Step 1. Locate the following safety equipment and supplies in the lab. First aid kit, emergency exits, shower, fire extinguisher, eye wash, waste containers, broken glass waste, safety glasses bin, gloves, and any other safety equipment and supplies in the lab. Step 2. Draw a diagram of the lab showing the location of the safety equipment and supplies. Step 3. Watch the lab safety video. Search online for lab techniques and safety. Crash Course Chemistry number 21. Step 4. Review the personal lab safety equipment shown in Figure 1.1. Step 5. Record and sign the lab safety agreement, which states, "I have been trained in lab safety, and I agree to follow the rules of the lab." D. Assessments. 1. Describe what you would do in each of the following situations. A. There is a chemical spill in the lab. B. A fire starts in the lab. C. A beaker breaks in the lab. 2. List personal safety equipment needed to work in the lab. 3. Name one rule that you learned from the video. Section 2. A. Activity 2. Pre-assessment. 1. When doing an experiment, why is it beneficial to alter only one experimental condition at a time? 2. How can you ensure that your experiment results aren't influenced by any outside conditions? 3. Discuss the answers to questions 1 and 2 with the class. B. Safety precautions. 1. Inform your teacher immediately of any broken glassware, as it could cause injuries. 2. Clean up any spilled fluids to prevent other people from slipping. 3. Wash your hands with soap and water after completion of the activity. C. For this activity, you will need the following. 1. Water. 2. Sugar or salt. 3. Beakers. 4. Ice. 5. Hot plate. 6. Thermometer. For this activity, you will work in pairs. D. Structured inquiry. Step 1. Hypothesize, predict. Examine the materials available in the lab. Think of a question you could examine about the available materials, e.g., does sugar dissolve faster in warm water than in ice-cold water? Formulate a clear, specific hypothesis that you could test during the lab period. Record your hypothesis in the data table. Step 2. Student-led planning. Design an experiment to test your hypothesis. Set up a data table in your notebook to record your data. Write out the steps of your experiment and devise positive and negative controls. Discuss your plan with your teacher before proceeding. Step 3. After your teacher approves, execute your experiment and record the data in your data table. Step 4. Critical analysis. Does your data support your hypothesis? Why or why not? What methods could you use to improve your results? Discuss with your partner and then write your answers in your notebook. E. Guided inquiry. Step 1. Hypothesize, predict. Redesign the experiment you previously performed in the structured inquiry. Create a more specific hypothesis, or create a follow-up hypothesis that you can test based on the results of the structured inquiry. Step 2. Student-led planning. Create a plan for your experiment, including controls and data tables. As before, your teacher should approve your plan before you start your experiment. Step 3. After your teacher approves, execute your experiment and record the data in your data table. Step 4. Critical analysis. Does your data support your hypothesis? Why or why not? How did you improve your experiment over what you did in the structured inquiry? How could you further improve your results? Discuss with your partner, and then write your answers in your notebook. F. Assessments. 1. What is the purpose of the scientific method? 2. You observe that plants sitting in one location in your house grow faster than plants sitting in another location. Create a testable hypothesis to test why this occurs. Then, describe an experiment that would test your hypothesis that includes controls. Section 3. A. Activity 3. Pre-assessment. 1. What are the conversions for the following measurements? A. 50 milliliter equals space liter. B. 20 gram equals space milligram. C. 700 microliter equals space milliliter. D. 1 gallon equals space point. E. 2000 milliliter equals space liter. 2. Visit the weighing station. What is the weight of a weighing boat? Some balances have a method of subtracting it by pressing the 0 or tare button. Weigh 3 items. Record the results in your notebook. 3. Discuss the answers to questions 1 and 2 with the class. B. Activity 3. Measurement. In the lab, you will need to use instruments to make your measurements. There are instruments to use for each type of substance, liquid or solid. Some of the instruments to measure volume are graduated cylinders, shown in Figure 1.4, and pipettes, shown in Figure 1.2 and Figure 1.3. Some instruments to measure solids are balances and scales. A scale is shown in Figure 1.5. You may also need to adjust the instrument or container you are using based on the amount of substance you need to measure. Figure 1.2. Figure 1.3. Figure 1.4. Figure 1.5. Also, when recording your measurements in a data table, it is important to be aware of significant figures. The number of significant figures is the number of digits needed to express the accuracy of a calculation. The rules for significant figures are presented in Figure 1.5. To use these rules, let's look at an example. An experiment requires you to measure the weight of 10 marbles. The scale shows a weight of 32.46547 gram. All the digits in this measurement are significant figures. However, in the number 32.465470, how do we know if the last zero is significant or not? There are 3 rules on how to determine significant figures. 1. Non-zero digits are always significant. 2. Any zeros between 2 significant digits are significant. 3. A final zero or trailing zeros in the decimal portion only are significant. So, based on this rule, the final zero in 32.465470 is significant, as is the first zero in 32.046570. However, the zero in 0.324657 would not be significant because it is simply a placeholder. C. Safety precautions. 1. Inform your teacher immediately of any broken glassware, as it could cause injuries. 2. Clean up any spilled fluids to prevent other people from slipping. 3. Wash your hands with soap and water after completion of the activity. D. For this activity, you will need the following. 1. A balance. 2. A weighing boat. 3. A graduated cylinder. 4. Weighable objects. For this activity, you will work in pairs. E. Structured inquiry. Step 1. Create a data table for your measurements and show your calculations in your notebook. Step 2. Hypothesize, predict, Examine one of the objects. Predict the object's mass, and write the predicted mass in your notebook. Step 3. Student-led planning. Listen to your teacher's instructions on how to use the balance. Discuss with your partner how you should determine the weight of the object and how many significant figures your measurement should have. Write your ideas in your notebook. Step 4. Determine the weight of the object using the scale. Repeat the measurement twice more, and record all results in your notebook. Step 5. Critical analysis. How much did your measurements vary among the 3 trials? Were you able to accurately measure to the amount of significant figures stated in Step 3? Why or why not? Could you have improved your methods to get more accurate measurements or obtain a greater number of significant figures? Why or why not? Discuss with your partner, and then write your answers in your notebook. F. Guided inquiry. Step 1. Hypothesize, predict. Volume is a measure of how much space matter occupies, and it is used to calculate density, d. d equals m over v, where m is the mass of the object, and v is the object's volume. Pick another object available in your lab and predict whether it has a higher or lower density than the object you used during the structured inquiry. Write your prediction in your notebook. Step 2. Student-led planning. How can you calculate the density of your 2 objects? Devise a plan for finding the density of both objects and present it to your teacher for approval. Create the data tables you need and decide how many times you should measure each object, as well as how many significant figures you will use. Step 3. After your teacher approves, take the measurements you need to calculate the density of both objects. Write your final densities in your notebook. Step 3. Critical analysis. How did the object's size influence its mass and its volume? What would you have to do to increase the mass, volume, and density of an object? How could you increase the accuracy of your measurements? Discuss with your partner, and then write your answers in your notebook. G. Assessments. 1. Why does the weight of the weighing boat need to be subtracted when measuring the weight of an object sitting in the weighing boat? 2. What is the most likely instrument used to measure the following volumes? A. 200 milliliter. B. 50 microliter. C. 1 liter. 3. Calculate the density of an object that is 3 gram and that displaces water in a graduated cylinder by 3 milliliter.